स्क्रीन शेयर है कि
आज्ञा मैडम हला
हां मैम हेलो
हला मैं मूव करिबा मूव ता देखा होची तो हेलो
ना मैम मैं मूव होउनी
अच्छी लिखुची स्टॉप शेयर से जुडे लिखुची रिज्यूम शेयर सेटा को क्लिक कर देबी
आज्ञा मैम
ओ ठीक अछि टिके रुह एमिति रिज्यूम स्लाइड शो लिखाई छी कोन हम करबी जानि परनी पुणी से दिन भूली जाई
मैम गोटे काम करंदो एबे स्टॉप स्क्रीन शेयर कर दंदो
कोन कर देबे काटी देबी
आज्ञा
हां हां एबे आसला एबे एइटा को क्लिक करछि एबे बदे हला
आज्ञा मैम
ओ ठीक अछि
एबे स्क्रीन मूव करंदो मैम मूव होछि मैम
हां होछि ना
ओके मैम
हां ठीक अछि तापर देखो वर्तमान हमें ई सब डिस्कशन करि सारथिले जोटा बाकी थिला हमें सेठी की जिबा तो मु मशीन लर्निंग ऊपर कहितली किछटा तो मशीन लर्निंग हला कोन आज मशीन लर्निंग विषय टिके कहबी तापर हम मोर मटेरियल शो करबी हला मटेरियल पढै देबी एटा 10 मिनिट 15 मिनिट खंडे पढैबी आ सेटा आधा घंटे पढै देबी ताले वर्तमान देखो मु सेदिन तुम कहितली सेदिन कोन कहितली जे मशीन लर्निंग टेक्निक विषय कहितली जे मशीन लर्निंग टेक्निक ता जानिबा को हेले मींस मशीन लर्निंग टेक्निक ता कोन कहले आगे तुम बेसिक ट्रेडिशनल टेक्निक सब जानिबो तापर मशीन लर्निंग टेक्निक जानिबो तो ट्रेडिशनल टेक्निक और मशीन लर्निंग टेक्निक भीतर मैक्सिमम डिफरेंस ता कोन ना ट्रेडिशनल टेक्निक रे तुम जहां भी गुटे मॉडल करिवो व्हाटएवर द मॉडल यू विल फ्रेम directly means just you are framing the model and getting the result, but you are not checking that whether that model is what percent level of it is accurate. Means whatever the model result it is giving, whether it is 100% accurate, means accuracy level or accuracy reliability level you cannot check. In the case for the case of means traditional model in the sense means econometric model. Any econometric model means regression and regression model, discriminant analysis, whatever you are saying means here you cannot go for checking that whether the model is 100% accurate or 90% accurate or whatever. But in case of machine learning, what is the difference? So the difference is that suppose 100 number of data points you have, okay, so out of 100 number of data points any 80-20 rule you can apply or 70-30 rule you can apply. So 80-20 rule means 80-20 rule means 80% of the data you have to go for training and 20% of data you have to go for testing. 80-20 or 70-30 also you can do of 100 data points. ताले 100 टा डाटा पॉइंट रु तमे 80 डाटा नै की तमे कोन करलो ट्रेन करलो मींस ताकू नै की स्टडी करकी ताकू गोटे मॉडल जे कोनसी मॉडल whatever the model you can frame, it may be regression model related to multivariate regression model, it may be discriminant, it may be logistic regression, it may be means you can say that cluster, whatever the multivariate techniques you can apply by using only that 80 data points. Okay, but 20 data points it will be like that, 20 data points it will be like that. So jo 80 data points se taku run karibo you can use this machine learning technique either in Python or means Python software or R package. You can go for R package or these two are usually we are using. Okay, so any 80 you cannot say that first 80 then 20 it will be leave. No, any 80 it will take from the data points out of 100 data points, then it will run and it will train it, then the final model it will come out. But in the case of machine learning, after getting the final model you can get also the result that what percent level of it is accurate. I mean what percent level of accuracy it is, that means that model is 80% accuracy or 90% accuracy or 99% accuracy. Everything you can find the information if you use machine learning technique. So out of that 80 data points you have to frame the model, then it is okay. So whatever suppose y equal to a plus bx, means height is equal to this is the weight, or this is weight is equal to this is the height. Suppose you have taken, then whatever the weight you have taken 80 number of exact data. Okay, whatever y, it is exact number of data. So after getting the model, another y value will get, another 80 y value will get, 80 number of y value, but that y value is known as what? Estimated value. So true value and estimated value, first you have to understand. True value means whatever it is given to you, that is your true value. But after fitting the model, another y value will get, another how many y value will get? 80 number of y values. So out of this y true value and estimated value, it will compare how many of 80 data points they are same with true and estimated. You are getting my point or not? True and estimated value means the software, it will compare, means through that algorithm only you can compare that one, means it will compare, and out of that 80, which one is mapping, how many data points are matching. Suppose 80 out of 80 it is matching, whatever the true data and estimated data through that model, whatever you have got the estimated data, then that means the model is 100% accurate. The model is 100% accurate. Suppose 90% it will accurate, I mean 90% it is matching and another 10% it is not matching, then 90% accurate. So from that only you can understand that how the model is a good one. Means you have to fit the best model through this machine learning directly. But in case of traditional technique, nowadays means previously all are applying only traditional model. They have no idea related to machine learning. That's why they are not checking that what exactly, only they are getting the results, nothing else. But the accuracy level, they cannot get that one. But here in the case of machine learning technique, you can get the accuracy level. Then what to do? After getting that, the model is accuracy, model's accuracy level is suppose 100% or 99, 95, whatever. We are getting that one. Suppose it is 80% accuracy. Then you can improve. You'll think that what I'll do so that my model it will be 99%. Then you have to think about that. There are so many things to do in case of that model. You have to ignore any particular variable which is not necessary to your model. So many different ways to rectify your model, and you have to improve your model up to 99% accuracy level. You can improve that one by yourself. So that is up to you, because you are getting that this is the 80% level of accuracy and I have to improve more so that it will be 99%. Then if it will be 99% or 100% accuracy level, then that means your model is the best one. So whatever the forecasting or prediction you do using that particular model and it is generalized, then it will be okay. Okay. Then what to do for 20 number of data points? So training data points, it is over. Then next will come to 20 number of data points. So 20 number of data points, that is for testing. That already I have told. Testing means that model, the 20 number of original data points, you have to what? 20 number of original data points you have to fit in that model, and you get whether it is equal or not. That also accuracy level you can test. That also accuracy level you can test for the rest of the 20 number of data points. You have to test for the model whether this model is good or not. Means you have the original data 20 number of points. For testing purpose, that 20 points you have to put in the model, and you have to go for testing whether the 20 number of original data points is equal to the 20 number of estimate data points or not. That is the testing point. For training, you have fitted the model. Then for testing purpose, you have to use that 20 number of data points, and you have to check whether 20 out of 20 it is matched with original true data and estimated data or not. Then you can refer that whether the model is good or not. So this is the rule of procedure to apply the machine learning techniques. I think it is the best method nowadays. This is known as advanced technology. So nowadays all the researchers, maximum researchers, if you use the traditional and machine learning technique, after that you compare your model, which one is the best one, that also you can find out. So those who wants to do research in future, so my suggestion is that you have to you have to learn machine learning techniques, and you have to take the training from any particular institute related to this machine learning technique. There are so many institute they are providing this type of course. Okay, short-term course or 1 year course, you can go for that and you can understand that one. And you have to you have to give your input in your research. So then next we'll come to the point that what are the different learning methods of machine learning. 3 different learning methods. One is your supervised learning, another one is your unsupervised learning, and last one, that is your reinforcement learning. So supervised, unsupervised, and reinforcement learning, how to differentiate all these? Supervised learning means I'll give you best example so that you can understand. This is the example related to supervised and unsupervised. Suppose you have the data points. Suppose anyone given to you that please you complete the project, and these are your data points. Okay, so these are your data points. You can see that some are from the figure supervised learning. You can see the figure. Some are cats and some are dogs. But these are the data points someone has given to you. That figures or pictures. Some are cats and some are dogs. But which one is your dog and cat? It should be labeled. It should be labeled in the data points directly. If it is labeled in the data points directly, then it is known as supervised learning. Means everything, it must be known to you from the data points. Suppose it is cat, it must be written cat. Suppose it is dog, it must be written. Means data should be clearly completed. The label points, everything you have known. Then it is known as supervised. If it's something it is not known, only the pictures it is given to you, but it is not labeled at all. Second one, unsupervised learning. Same figures, cat, dogs, here also cat, dogs, but here it is labeled. You can see that here it is labeled as cat and dog, but here it is not labeled, it is cat and dog. That means it is unlabeled data. It is labeled data, it is unlabeled data. Label and unlabeled means supervised and unsupervised. So first, as you are the new learner, first you have to start from the supervised learning. Means the techniques for supervised learning, what type of technique you can apply, that is your regression techniques, classification techniques. Here I have written, everything I have written. For label data, you can go for prediction, and you can go for the prediction means regression analysis. You can go for regression analysis. It is in your course. I will make you understand multivariate regression analysis afterwards. Third unit, I think. Then classification also you can do, means classification cluster techniques, and another different discriminant analysis you can do. Classification you can use for unsupervised. Only for that in case of supervised, classification also you can do. Classification you can do, regression and ranking also you can do. Suppose there are 100 number of universities in state university you have taken, which one is rank 1 and which one is rank 2 according to the criteria. That ranking procedure also you can do for supervised learning, because all the information it is known to you. That's why. Similarly, classification, that is classification you can take classify, means which one is coming under that central university, which one is coming under open university, which one is coming as your state university, level A, level B. Classification also you can do. Okay, then regression means prediction purpose. Prediction means you can predict weather forecasting, you can predict which customer is loyal one. Then a different type of prediction you can do, that is your by using regression. Okay, so I think all of you are getting the meaning of supervised learning. Then I'll come to unsupervised learning. So unsupervised learning means the label it is not given, nothing it is given to you. Only suppose pictures, suppose only data, label pictures only it is given to you, and some different type of varieties of data data points it is given to you, or different type of means information it is given to you, but not label. What label? For this is the data for what it is not given to you. Then you can go for clustering, means classification clustering, dimensional reduction means factor analysis you can do. Any estimation related to this unsupervised learning, you can go for that one. Okay, then reinforcement learning means means that is the more advanced technology of machine learning. That is, suppose anyone interest for, means first advance is supervised, next advance is unsupervised, next advance is reinforcement learning. Now researchers are means doing this one, and they are doing going on research for this means development of the robots. Suppose driver without car driving without driver. That is that type of model or that type of analysis you can do for reinforcement learning. Okay, robot designing. This one you can do for this one. It is known for reinforcement learning. So like this way, now we'll come to some applications of machine learning. Some applications of machine learning means you can check that internet also, robotics, healthcare, biology, computer vision, NLP, natural language process. Suppose all of you have known from Hindi to if you want to translate English, Odia, English, Odia, that is also machine learning technique. Through machine learning technique only you can do that one. Okay. Then sensor, spam reduction, then spam identification, then Netflix means online purchase, everything, each and every means area, research area, you can apply this machine learning technique. Okay, means biology, computer science, healthcare sector, then you can say that physics, chemistry. Now I'll make you understand that how it will be applicable in social media. Suppose anyone will purchase that particular product. Suppose he or she will the adult type, whatever the wantings of adult age group, it will come to directly on the online purchasing. That means machine learning technique. Here also machine learning technique it is applied. Okay, that means online purchase. Similarly, in chemistry, chemistry also machine learning algorithm they have to apply for best chemical bondings or whatever they have to find out. Then machine learning technique also it will be applied in image recognition, that who is the most wanted crime, that also they can find out. In crime branch they are usually using this machine learning technique to for image recognition, like that way. So nowadays each and every area, finance, biology, finance means forecasting purpose, stock market forecast, accurate forecasting, it will be necessary for investor, that what should be the exact actually forecasting of the stock market. Okay, stock market or weather prediction, anywhere you can use that machine learning technique. And these are some books you can refer these books for initial reading. After that you can go for any training 1 year so that you can understand how to do that one. So like this way, so these are some examples of text mining research. And now I'll make you understand that that these are the steps already you have discussed. Now I'll make you understand about univariate analysis. Univariate means data. First I'll make you understand that data points, it may be metric, it may be non-metric. Okay, metric or it may be non-metric. So metric data points means if it is a quantitative value 2, 3, 4, 5 like that way directly you are getting from the questionnaire, then it is known as metric data, means numerical figure. Non-metric means it is a qualitative data. Qualitative data means, so metric and non-metric. Metric also you can get that numerical figure, but there are two types. One is your first you have to understand about the variable, then only you can understand that metric and non-metric. Okay, so variable, there are 4 types of variable: nominal, ordinal, interval scale, and ratio scale. So nominal data means nominal data means the data which is categorical. Categorical means that married, unmarried, educated, uneducated, then male, female, like that. Okay, so here from the questionnaire directly you are not getting the numerical figure. Only you are getting married, unmarried, they will put the tick mark. Only you are getting male or female, M or F you are getting, or you are getting that educated, uneducated, like that. Means from that only you have to give the code for analysis purpose. That's why it is known as categorical data and this is coming under non-metric. These are coming under non-metric. Okay, categorical data is coming under non-metric data. Then ordinal, what is ordinal data? Ordinal data means, suppose you are the customer. Okay, I want to go for study research on mobile. So according to you, which mobile is rank 1 and which mobile is rank 2? I am giving you the questions because I am the researcher, and there are 5 number of mobile company name, brand names, and out of that which one is a rank 1, and according to you which one is a rank 1, rank 2, like that. But according to another customer it may be rank 2. Suppose you are giving that Apple as a rank 1, someone is giving that Samsung is rank 1, like that way. So ranking type of data is known as ordinal data. Then it is coming interval scale. Interval scale means suppose any that scale type data means any statement you are giving, you are converting it into quantitative form. Highly agree, extremely agree with that particular statement, then medium, then low degree, then like that way 5-point scale or 7-point scale or 10-point scale, all it is known as interval scale. Interval scale means you have to give the scale to differentiate your statement or your thinking. Okay, it may be highly agree, highly satisfied, it may be never satisfied. So medium also that. So it may be 5-point scale, you can differentiate a your scale, or it may be 10-point, it may be 7-point, whatever. But the quality means the statement, it is quantified, it is you have to quantify it as in the form of scale. Okay, so then it is known as that ratio scale, sorry, interval scale data, but it is metric, because directly from the questionnaire, you are getting means a numerical figure, Okay, so then it is known as interval scale. Next it is coming that ratio scale. So ratio scale means that the data which is directly coming from the questionnaire, it is means numerical figure. That means the data which relates to units of measurement. The units of measurement means some data it is related to rupees, means income group. The data it is coming in rupees, that is ratio scale data. The data related to that weight, it is related to kg, so it is your ratio scale data. Data related to any millimeter, centimeter, or you can say height, you can take that rupees. So any form, the data in the form of units of measurement means data directly coming, numerical figure means from the questionnaire, that all the data it is known as ratio scale. So now I think from this variable you can understand which one is your metric data and which one is your non-metric data. Non-metric data, that is your nominal and ordinal, otherwise you can say categorical data is known as non-metric data. That you have to categorize, that is known as non-metric, means you have to give your code by yourself, because the data whatever it is coming from the questionnaire, it is not in the form of what? Numeric value. Then it is coming interval scale, ratio scale. In interval scale and ratio scale, both these two are what? Metric data. So metric data and non-metric data, all of you are clear? Hello?
Yes, ma'am.
Madam, nominal and ordinal are non-metric, right?
Yes.
And interval and ratio scale are metric, right?
Yes. Then theory note, already I have the material I have shared to madam. I'll show you afterwards, or after getting the material you can read and you can understand, or any book also you can follow. Okay, I think all of you are getting the variable and data. Hello?
Yes, ma'am. Yes.
Okay, next we'll come to metric data. Metric data, already we have discussed that it must be a numeric value. The numeric value means you can differentiate it as individual, discrete, and continuous. Individual, discrete, and continuous. So what is your individual and what is your discrete data and what is your continuous data? So individual data means suppose 10 number of students and 10 number of students, they have scored 10 different marks. Then you can differentiate it as individual data. Okay, 10 different marks and 10 number of students. But that 10 number of marks, it is repeated for 2-3 students, like that. Then you can convert it into discrete. So individual data means there is no frequency. Frequency means what? The repetitions of the data. Repetitions of the data means somewhere the data is repeated for 2-3 cases. Then instead of writing individually, you can convert it into a group. So on group and group. On group means there is no frequency, that is your individual data. If there is frequency, then it is known as either discrete or continuous. Discrete data, when you take, if it is an integer figure, then you have to take discrete. Discrete means it is an integer figure, data itself it is an integer figure, then you have to say it is a discrete, but there must be frequency. Frequency means repetitions of the data points. Then continuous, if the data it is fraction, means in centimeter, means height means it will be centimeter. Centimeter means it may not be always integer, It may be some fraction means point decimal. If it is a decimal form, any data decimal form, and it is repeated, that means you have to frame the frequency, and it is a continuous data. The data itself, it is a fraction, and number of repetitions also there. So individual data, discrete data, and continuous data. I think all of you are clear. Individual means a single data. If it is there is no repetition at all, then you can say it is an individual data. There is no frequency at all. If there is frequency, it may be discrete, it may be continuous. Discrete means the integer figure, it is there, data itself, it is an integer only, scores. A score, if all are integer, then you can take it as discrete data. But in case of continuous, if the data points, it is coming fraction, then you have to take it as continuous data points. So next we'll come to, after getting the information all about that related to data, then what to do? You have to go for univariate analysis. There are 3 types of analysis already I have told, that univariate, bivariate, multivariate. So univariate, bivariate, multivariate means what? Univariate means single variable analysis, single data points, not data points. Data points means each one. Variable means single variable. Suppose only height you have taken, height of the 100 students. That is your univariate analysis. Okay, univariate analysis. So what type of univariate analysis you can do? You can use what type of methods you can use? That is your mean, median, mode, standard deviation, quartile deviation, mean deviation, range, then skewness, kurtosis. All these are the Z-test, T-test, chi-square test. I will make you understand because it is in your syllabus. But mean, median, mode, it is not in your syllabus. Just I'll briefing it. Mean, median, mode, you have to go for descriptive statistics, or and standard deviation also coming under descriptive statistics. Okay, so what is your mean, median, mode? Mean means the value which covers the entire data. Central tendency means central value which represents the entire data is known as central value or central tendency. So mean, median, mode. Mean is your arithmetic mean. Okay, usually we are using arithmetic mean. Median and mode, specific cases you can use that one. Okay, for salary purpose you can use median, and for height purpose you can use mode. Okay, there are some specific cases you can use that median and mode, but generally we are using mean. Then all these are you can use for ratio scale data. Ratio scale data means height, weight, salary, income, or you can take any type of numeric metric data. You can use mean, median, mode, and standard deviation, quartile deviation also. Standard deviation, quartile deviation, what you can study for standard deviation? Measure of variability or dispersion. What is measure of variability? Measure of variability means, suppose there are 100 number of weight you are getting, weight of the students, 100 number of students weight you have taken, same group means PG students. So variability, I think it will be less because you are taking only PG group students. It may be only that it may be varies from 50 kg to 65 or 70 kg. Okay, the variation it will be, I think, less. If you take 100 number of another students means PG students, then +2 students, then 10 class students, if you take, then the variability it will be more. That 100 students you take only for the group of PG students, and that 100 number of students you will take mix with 10 class, +2, +3 and PG, then I think the variability it will be more. So for variability study, you can use that measure of dispersion, that is your standard deviation, quartile deviation, or mean deviation, or range. But best one, that is your standard deviation. Similarly, best measure of central tendency, that is your mean. Best measure of dispersion, that is your standard deviation. Best measure of central tendency, that is your arithmetic mean. Then what about that skewness and kurtosis? Skewness and kurtosis, what you'll study? Skewness and kurtosis means you can study the symmetricity of the data, normality, whether the data points are normal in nature or asymmetrical in nature. Normal opposite is, normal is known as symmetrical. Either way you can say that symmetrical, or it is otherwise asymmetrical. So symmetrical means how you know that the data points are symmetrical. I have already told, if the variability is less, data is symmetrical. Accurate means consistent, or you can say consistent, you can say reliable, you can say efficient, or you can say accurate. You can say that means variability is less. Suppose you have taken 100 number of data points of PG students only, then data is symmetrical. I think if you plot, you'll get normal type curve. Okay, normal type curve. If we take another data points of 100, those who are mixing with 10 to PG, then that is not a symmetrical data. Asymmetrical data. Asymmetrical means it is a skew data. It is a skew data, skewness. So for skewness, you can study whether the data points are symmetrical or asymmetrical. So asymmetrical means skewed. So skewed means it may be positively skewed, it may be negatively skewed. So first curve is known as symmetrical, second curve is known as asymmetrical, means skewed. So skewed is positively skewed and negatively skewed. So another way to know that whether the data points are symmetrical or not, that if you find the mean, median, mode, if all are coincide means mean equal to median equal to mode, then only you can say the data is normal. Data is normal. If mean is not equal to median, is not equal to mode, then you'll say that it is asymmetrical or skewed. Okay, so skewed, I think skewness, all of you have got the idea related to normality and skewness, or asymmetrical and asymmetrical, the difference you are getting. Then this is the point where you can understand that what is your normal curve. The mid one is your normal curve, means mean, median, mode all are coincide, means all are equal. Okay, if it is not equal, then it may be positively skewed, it may be negatively skewed. Okay, positively skewed and negatively skewed. So like this way, I think all of you have got the meaning of positively skewed, negatively skewed, and normal distribution. And that real life example also I have given, that 100 number of students of only PG group you are taking, and 100 number of students you will take from 10 plus 2 plus 3 and PG, 4 number of groups, and you go for the weight of all these and you plot that one, you never get normally distributed. They are not normally distributed. They may be positively skewed, they may be negatively skewed. The curve, it will be like this, positively, the longer tail it will towards the positive side, then it will be positively skewed. If the longer tail proceed towards the negative side maximum, then it is negatively skewed. So I think all of you are clear the meaning of normal distribution, negatively skewed and positively skewed. All of you are getting? Hello?
Yes, ma'am.
Okay, very good. Then next we'll come to so univariate analysis, I think all of you have got univariate analysis, mean, median, mode, only single variable you have to study. Only we have taken weight, suppose. So Z test, T test, chi-square test, all these tests you can apply. So that I'll make you understand afterwards. So first you get that material, then only we'll discuss that one. Okay. So then now we'll come to that bivariate analysis. Bivariate analysis means correlation and regression, means two variable. You have to study for the two variable. That height and weight. As you know that height and weight are related with each other. So if the height is more, then obviously weight it will be more. That means weight is depending upon the height. Maximum cases, weight is depending upon height. So here I am saying that estimation purpose, you can use bivariate analysis, and for prediction purpose, you have to use that regression analysis. Means first you have to go for correlation. If there is relationship, then only you can go for regression. If there is relationship only, you can go for regression. Otherwise, there is no meaning to frame the model for regression analysis. Okay. Another technique is also related to that bivariate analysis, that Z test, T test, F test. For non-parametric also, chi-square test, Kolmogorov-Smirnov test, Run test, Sign test, Wilcoxon test. So all these tests are related to non-parametric test and parametric test. So parameter and non-parameter, what is the difference? I'll make you understand afterwards. Just you have to know that parametric test, it is the Z test, T test, F test are coming under parametric, and all these. So parametric means that metric data. The test related to metric data is known as parametric. The test related to non-metric data is known as non-parametric test. Okay, non-parametric test. Then time series analysis also, you can go for time series analysis by using bivariate data. Okay, bivariate data. Then next one, it is coming multivariate. That is the most important one. those who wants to do the research or any project, those who will handle the project, because you are the MBA students. I think in the 4th semester, any semester, you have to complete the dissertation or project work. At that time, all these techniques, it will be very useful. From all these technique, I will make you understand that it is in your syllabus: multivariate regression analysis, ANOVA, discriminant analysis, I think. Okay. And multiple correlation analysis also I will teach you. Okay. It is not in your syllabus, but I will teach you. So these are some techniques related to multivariate technique. And multivariate analysis means more than 2 variable. More than 2 variable, then it is what? It is what? Multivariate multivariate analysis. But one thing you have to remember, that multivariate techniques you can use for metric data, both for metric and non-metric. Okay, both for metric and non-metric data, means that ratio scale data you can use, interval scale also you can use, and that categorical data also you can use for that multivariate analysis. Okay, so now I will make you understand that dependence technique. What are the techniques? ANOVA. First, what is the meaning of ANOVA? Why you are using that ANOVA? I will give you best example so that you can understand. So ANOVA means for variability testing, you have to go for ANOVA. Variability testing means, suppose there are in your town, suppose there are 5 different malls. 5 different malls. For 5 different malls, any particular product pricing strategy you have to know. So pricing strategy you have to study for 5 different malls, whether the pricing strategy of the product, it is same in nature or it is different. It is different. So this type of analysis if you want to do, because there are 5 different malls, and whether these 5 different malls, 5 pricing strategy, it is equal or different, you want, or it is variable in nature. If you want to study, then ANOVA you have to apply. Analysis of variance, ANOVA. Okay. Similarly, what is discriminant analysis? Why you are using discriminant analysis? For discrimination means for classification and prediction. For classification and prediction means that you have to use the prediction. You have to go for prediction after classification. That means suppose in your college or in your institute, boys and girls, their CV, you have collected the CV. Through that CV, whether they are getting job campus or not, they are getting campus or not. Suppose they are getting campus, and whether it is boys and whether it is girl, means classification. It is classification means boys and girls classify you have done. Then you have to go for prediction that whether he or she got the job or not. Okay, after completion of the BTech or after completion of the MBA, whether that boy or girl got the job or not, that type of prediction you can do, and also you can directly classify that boy or he is the boy or she is the girl or not. So this type of analysis you can go for. What type of analysis you can apply? The discriminant analysis. Okay. So here multivariate techniques, because so many variables you have to take, whether he will get the job or not, criteria. Okay. Similarly, logistic regression, also classification and prediction. So classification, prediction, the difference is that logistic and discriminant, there is some conditions, internal conditions. Whenever I will make you understand about discriminant, I will make you understand what is the difference between the discriminant and logistic. Okay, the logistic regression also, it is not in your syllabus, but I will make you understand. Okay, and how to do the through SPSS software also, I will give the steps so that those who can use that SPSS software, if you have the laptop or any system, you can download the SPSS software or collect that one, and I will make you understand how to go for analyze by using the technique ANOVA, discriminant analysis, logistic multivariate regression. Everything I will make you understand. Next one, that is your conjoint analysis. So conjoint analysis means product designing. Any type of designing purpose, I already have told that suppose you are the entrepreneur and you want to launch the new product, and according to the customer demand, what should be the design of the product that you have to fix. Okay, that you have to fix, and by which technique? That is your conjoint analysis. So product designing, what is the product design of your product, according to the customer's demand, that how we'll do that one? Through conjoint analysis only. Then next one that is coming, multivariate regression analysis. Multivariate regression analysis, cause and effect. Already I've told height and weight, or you can say that boys and girls getting job or not, any type of prediction, weather forecasting, cause and effect. Then you can go for that you can that whether you'll invest or not, or any type of cause and effect relationship. It may be related to physics, it may be related to economics, it may be related to finance, it may be related to that weather. Any type of cause and effect relationship means if the data contains the metric data only, then you can go for multivariate regression analysis. Then multiple correlation, that is obviously relationship exists or not, you can study through multiple correlation. Then ANOVA variability, that is ANOVA, and this is your multiple analysis of variance. This is little bit different from ANOVA. Then canonical correlation. Canonical correlation, another type of relationship if you want to study, then it is known as canonical correlation. Next one, it is coming factor analysis, cluster analysis, multidimensional scaling technique. So within 5 minutes, I'll make you understand that what is factor analysis, why you use this factor analysis. Factor analysis you have to use for data reduction. So what is meaning of data reduction or variable reduction, dimension reduction you can say. So what is the meaning of dimension reduction or variable reduction or data reduction? Not data reduction, actually variable reduction. So what is the meaning of that? So meaning is that suppose you have framed, you have variable 30 number of variable. The 30 number of variable it is there. Height, weight, age, then income, then like that way 30 number of variable. But according to that according to your objective, maybe 30 number of data points, it is not what? It is not important. So it is not necessary or important. That means through factor analysis, you have to reduce the variable. That means out of this 30 number of variable, it may be reduced to only 5 number of factor. The 30 number of variable reduced to 5 number of factor. That means some variable merge with one factor, some variable merge with another factor, some variable merge with another factor, like that we have 5. Okay, so with this 5 factor, you can proceed further analysis. Further analysis means you can proceed to regression analysis, you can proceed to any type of parametric, non-parametric analysis or test. Okay, then you will come to cluster analysis. Already I have told cluster analysis you have to use for making the cluster. Okay, that it is coming under which cluster. Some there are so many criteria it is given, whether it is coming under urban group, whether it is coming under slum group, whether it is coming under village group, whether it is coming under semi-urban group, whether it is coming under that semi-village group. Like that way, cluster analysis. Through that cluster analysis, you can get that classification. You can use it for classification or segmentation. For market segmentation also, you can use that cluster analysis. Marketing people. Then multidimensional scaling. What is the meaning of multidimensional scaling and why you are using that multidimensional scaling technique? That is brand positioning. What is the position of your brand? Suppose you are the manufacturer. You want to know that your brand, what is the position suppose you are the manufacturer, what is the position of your brand in India or in Odisha? What is the position of your brand? Means there are suppose any particular product, there are so many brands. 10 number of brands it is there for any particular product. Cell phone, you can take TV, you can take computer. So what is the position of LG? What is the position of Apple? You can study that through multidimensional, whether it is standalone or whether it is similar. Like suppose for the university also, all the state university in India we have taken, all the central university we have taken in India, and what is the position of central university of this, central university of that, you can study according to the so many criteria. Okay, it may be related to metric data, it may be related to non-metric data, whatever it may be, that you can study through this multidimensional scaling technique, and you can analyze whether that particular university is standalone or this particular university and that particular university, they are coming under one group or whatever, everything you get from this multidimensional scaling. So I think all of you are clear. related to just, I think I have given only the brief idea of what exactly the meaning of data and different type of analysis. It is related to whether it is related to univariate, or it is related to bivariate, or it is related to multivariate. I think all of you have got some information or not.
Yes, ma'am.
Very good. Okay, the material today I think madam will share, or you can give me the mail ID so that I'll provide you today only. Okay.
Already I message ma'am in your WhatsApp.
Message. Okay, then now I will proceed to my department. So thank you. Next, I think madam will give me the slot. Otherwise, coming next class I will discuss. Okay, I'll leave. So please. Now I'll leave. Thank you. I think today, but less number of students they have joined.
Ma'am, due to the maximum number of students for the employees.
Last class, I think so many students, 90s, but today it is less, 50s only. Okay. Anyway, I'll leave this one. Thank you. Thank you all.
Okay, ma'am. Good day, ma'am.
Rahibi? Okay. Oh.
Yes, ma'am.
Now I may leave.
Yes, ma'am.
Okay. Thank you.